friends, in our last session we have completed with Lancashire boiler, and today's session we are also going to see accessories, along with that some mountings which are remaining. So let's begin with that. This is Faizan Kagdi and I welcome you all to our lecture series of basic mechanical engineering. So the first type of mounting is fusible plug. Now what is fusible plug? So we would say that fusible plug is a mounting which is mounted on the outer surface of a combustion chamber, but it is provided inside the boiler shell. Remember, it is mounted on a top side of a combustion chamber. Now, what is the purpose of a fusible plug? So we would say that it is going to act as a safety valve. Okay, it is going to provide safety to a boiler. Now against what? So we would say sudden explosion of a boiler. Now how it can occur? So we would say that, for example, a water level inside a boiler, as we know, we have to maintain within a safe water limit, but because of some reason operator was not able to maintain that, and it due to its negligence. So what is going to happen? So we would say the level of water can be reduced in a boiler shell and a level of steam will increase in that boiler, right? Now if a steam level increases, then we can say that in entire boiler there will be a steam and a circulation of that steam will take place, right? So that hot gases will transfer its heat energy to a steam, which will lead to a more superheated steam. Along with that, it will also increase the pressure of that steam. A condition can come that the entire boiler can explode due to the increment in a pressure, okay, and due to the formation of a steam in an entire boiler. So this can be avoided by placing a fusible plug on the top of a boiler shell. Now how it is going to provide a protection? So the construction of a fusible plug is such that it is made up of three gunmetal bodies. That is, you can see a gunmetal body A, gunmetal body B and gunmetal body C is shown. Now why we are calling it as a gunmetal body? Because it is made up of a red brass from which a bullet is made. Okay. Now if you see carefully, then we have a gunmetal body C which is of a conical shape. Okay, that gunmetal body C is connected or joined to a gunmetal body B by means of a fusible metal. Fusible metal means that metal which can be easily melted out. Okay, that can be fused out, which means it is made up of a tin or lead. So in normal condition, we can say that this entire fusible plug will be submerged in water, but when a level of water is below the safe limit and when a steam comes in contact with this top surface, so what is going to happen? So we can say that as soon as the steam comes in contact with this metal, the metal will melt. Why? Because the temperature of a steam will be much higher compared to that of water. So it is going to melt, and as a result of which the entire conical plug C will directly enter into a combustion chamber. Okay, the falling of this fusible plug or conical plug into a combustion chamber, I would say, will directly provide an open passage to a steam to rush into a combustion chamber, which means the steam will enter into a combustion chamber. Now what is going to happen? We know that within a combustion chamber hot gases are produced, combustion is taking place, right? So as soon as the steam comes in contact with the combustion, that is coal, we can say the combustion of coal will get stopped and we would say production of a steam will be stopped. Hence we can say that it has provided protection to a boiler against certain explosion which could take place if the steam would have not rushed into a boiler shell because of a fusible plug, right? So we can say that it has provided protection to a boiler against sudden explosion when a level of water inside a boiler shell is below a safe water limit by directly allowing a steam to enter into a combustion chamber. Okay, now let us see that it is fitted on a firebox crown plate over the combustion chamber. It consists of two hollow gunmetal bodies and one conical plug that is also made up of a gunmetal body. In normal working condition, we can say the upper surface of a fusible plug is covered with water and the other end of a plug is exposed to fire and or hot gases. But when a water level in a boiler falls below a danger level, then we can say a fusible plug is uncovered by water and get exposed to the steam. Now further we can say this overheats the plug, and a fusible metal like tin or lead having a low melting point will melt quickly as the temperature of a steam is much higher. Thus the plug drops down and hollow gunmetal body B becomes open. The steam rushes directly into a furnace and puts the fire to stop. Okay. Now let us see next step, that is called a blow of coke. So the function of blow of coke is to remove the mud particles and sediments which are collected at the bottom of a boiler shell. Okay, so the construction is very simple. As you can see on the top side, there is a guard and a shank yoke provided. So basically we can say a spindle is provided, and the bottom side of a spindle is connected with a plug which is having a rectangular hole. So in this case, in your diagram, you can see a trapezoidal shaped plug. Okay, so the hole is also of a trapezoidal shape. Okay, now how it's going to operate? So we can say that if we rotate a spindle in such a way that a hole is in perfect alignment with the axis of a valve body, then a water along with the mud particles will flow out from a boiler shell. And when we don't require to drain the water and mud particles from a boiler shell, then what we are going to do? Then just we are going to bring a solid portion of that plug in a alignment with a valve body. So it is very simple that when a hollow conical plug is brought in alignment, then mud particles and water will release from a boiler shell, and when a solid portion of that plug is bring in alignment with the valve body, then it will stop the flow of water. Okay, now let us see that. So as you can see on your screen, I have written it. It discharges periodically a portion of water which contains a mud, scale or sediments from a boiler shell. It also used to empty the boiler when necessary for cleaning and inspection purpose, which means two purposes are done by this valve. The first purpose is to remove the mud particles, and second purpose to empty the water from a boiler shell at a time of cleaning and maintenance. Okay, it is fitted on a boiler shell directly at the lowest part of a water space. So remember that on a lowest portion, this blow of coke is provided. Why? Because mud particles gets collected at a bottommost portion. Okay, very simple. Now next, it consists of a gunmetal conical plug having a rectangular hole, spindle with a yoke. Okay, and rectangular hole of a plug is brought in line with casing hole. By rotating the spindle, the water will flow out. When a solid portion of a plug is in front of a casing hole, then we can say the water cannot flow out of a boiler. Okay. Now next step is a feed check valve. Now as we know the function of a feed check valve, as the name itself suggests, it is going to feed water into a boiler shell. Okay. Now the construction, let us see the construction and working. So as you can see, the hand wheel is provided on the top side of a spindle, and the bottom side of a spindle is not connected with a valve. Okay, so there is a valve which is provided that is called a non-return type of a valve, which means it is going to allow the flow of water only in one direction, that is in an upward direction. Valve is resting on a valve seat, and on this left side you can see it is a portion of a boiler shell. Okay, which means the connection to a boiler shell, and a bottom portion of a valve body represents a water inlet, so that portion will be connected to the water pump. Now as we know that water inside a boiler shell will be at certain height, so pressure of a water inside a boiler will be much higher. So it is required to feed a water by means of a pump. Okay, so that bottom portion of that valve will be connected with a pump. So delivery pipe of a pump. Okay, so water inlet indicates water is forced into a boiler by means of a pump. Because of that, a non-return type of a valve will be lifted up and water will begin to enter into a boiler shell. Now, basically what a spindle is doing, so we would say a spindle is maintaining the quantity of water to be supplied. When we completely close a spindle in a downward direction by rotating a hand wheel, so we would say that water will not come inside a boiler shell. When we completely open a spindle, that is moving a spindle in upward direction, then we can say that maximum amount of water can enter into a boiler shell, because it is basically controlling the opening of a non-return type of a valve. Okay, and if we partially open a spindle, then we can say we can reduce the quantity of water to be supplied into a boiler shell. Okay. Now next question comes over here, that why a non-return type of a valve is not directly connected with the spindle. The reason is that for some reason, for example, the pump has been suddenly stopped. Okay, so what could happen? So if we have provided the connection of a valve directly to a spindle, so we can say a backflow of that water from a boiler can take place inside a pump, right? That will reduce the quantity of water in a boiler. So to avoid that, it is required to provide a non-return type of valve. Okay, so let us see that. It controls the supply of water to a boiler. It is fitted in a water space of a boiler just below the normal level of a water. It consists of a non-return valve, water inlet pipe, outlet pipe, spindle, gland and handle. Inlet and outlet pipe of a valve exposes direct pressure, and this pressure difference lift the non-return type of valve, which allows the flow of water into a boiler shell. The lift of valve is controlled by moving the spindle up and down with the help of a hand wheel, and so flow of water is controlled. Now the next type of a valve is called a steam stop valve. So we know the function of a steam stop valve. The function of a steam stop valve is to take the steam out from a boiler shell. Okay, that is the steam generated will come out through this valve. Okay. Now the construction is very much similar to the feed check valve. The bottom portion of a flange you can see is directly connected to a top of a boiler shell, and whereas the right side flange you can see is where the steam out is written is connected to a pipe where a steam has to be supplied. Okay, so it is very clear. Now hand wheel is provided on the top of a spindle, and bottom side of a spindle is connected with a valve, and a valve is resting on a seat that is called a valve seat. Now in normal working condition we would say the valve is going to remain closed. Okay, but when we require to take a steam out from this valve, so we are going to rotate a hand wheel. The rotational motion of a hand wheel will lift the spindle in upward side, and it will also lift the valve. That steam from a boiler shell will begin to enter into a valve body and will finally leave the valve body. Steam will come out from a boiler shell. Okay. So it regulates the flow of steam from a boiler to the steam pipe. It is fitted to a boiler at the highest part of a steam space, which means at the top of a boiler shell. The spindle is rotated by help of a hand wheel. Due to rotation of a spindle, the valve moves up and down. When a valve sits over the valve seat, the passage of a steam is completely closed. Okay, now let us see our next topic, that is economizer. The function of economizer is to preheat the water, and then after preheating it, supplying it into a boiler shell. Now how a heat transfer takes place to preheat the water? So we would say we are going to use the heat energy of a hot gases which release to the surrounding atmosphere through the chimney. If that heat energy is not utilized, then it will be wasted to the surrounding atmosphere. So economizer is basically doing nothing but using a heat energy of a hot gases which are leaving the chimney just to preheat the water before supplying it into a boiler shell. Okay, now let us see the construction. So you can see a top header is provided and a bottom header is provided. To a bottom header there is a feed water inlet provided, so that a water, that is a normal water, will enter through the feed water inlet into a bottom header. Through a bottom header it will flow in upward direction to the cast iron tubes which you can see, and finally will reach a top header. Now how a heat transfer will take place? So you can see from a left side a flue gases inlet is shown, and from a now what is going to happen? So we would say heat transfer will take place from this flue gases to a tube. In return, tube will get heated up, and finally the water which is flowing in upward side through the tube will get heated up, and on the top side the water which is going to enter into a top header will have a high temperature, which means a hot water. Finally that hot water will enter into a boiler shell through a feed check valve. So it is written on our left side, you can see feed water out, which means that valve is a feed check valve which is directly connected to a boiler. Now, periodically what is going to happen? So we need to clean the outer surface of these water tubes. Why? Because hot gases consist of fly ashes, that is carbon ashes, which can stick on the outer surface of this tube. If it sticks, then it is very obvious that heat transfer rate from a hot gases to water will reduce. So for that purpose, a soot scraper arrangement is provided, so that scraper will move continuously up and down on that tubes in order to remove the soot particles, that is carbon ashes, and that ashes will be collected at the bottom side of an economizer. So as you can see, it increases the temperature of feed water using a waste heat of a flue gases leaving the boiler through the chimney. It consists of a large number of water pipes. From a bottom pipe, the water transfers into vertical cast iron pipes, and hot gases flows over that vertical tubes. There is a heat exchange between a water and a hot gases, and temperature of water will increase. This water is finally going to supply into a boiler. Advantage is, so fuel consumption in a boiler reduces, right? Why? Because we are directly supplying a heated water into a boiler, which means it is going to take less time to generate steam, right? In a less time, steam will be generated easily, and as well as the benefit is that the consumption of coal will also be reduced. So increased evaporation capacity of a boiler, reduced boiler thermal stress, so boiler life of a boiler will be increased, which means it is going to increase the overall efficiency of a boiler. Next is the superheater. So the name itself suggests that superheater is going to superheat something, right? Which means it is going to convert a dry steam into a superheated steam. Now let us see the construction of this superheater. So the boiler in which this superheater is used is a Lancashire boiler. So the construction of this boiler is also shown over here. This rectangular shape you can see that is shown by yellow color is a boiler shell of a Lancashire boiler. Okay, and the bottom arrangement entire is a brick construction. So there is a bottom passage shown, and there is a boiler tube, that is fire tube is also shown with the boiler shell. Okay, now we need to understand the construction of a superheater. So you can see a U-tube superheater is shown at an exit of a main fire tube. Okay, and at the top side there is a connection also shown. Now let us understand its working. So in a normal condition we can say that on the top side of a boiler shell the steam will be a wet steam. It will pass into a anti-priming pipe to generate a dry steam. Now that dry steam will flow in an upward direction. Now it has a two passage. One passage is for a superheater tube to enter into a superheater tube, and second passage directly through a valve V3 it can exit through a boiler shell. Okay. Now when we don't require a superheated steam, so what we are going to do? We are going to close valve V1, okay, and valve V2. Both the valve will be closed and we are going to open a valve V3. When we open a valve V3, we can directly get a dry steam from this boiler. But when we require a superheated steam, so what we are going to do? So we are going to close this valve V3 and we are going to open valve V1 and valve V2, which are represented by red color, you can see. So at that time, that dry steam will pass through valve V1 and enter into a superheater tube. Now this superheater tube is directly entering inside a brick construction, you can see. Now what is going to happen over here? So these hot gases which are coming from a main tube, that is fire tube, will come in contact with that superheater tube. Heat transfer will take place from that hot gases to a tube. Tube will get heated up, and in return the dry steam which is flowing through that tube will also get heated up and finally get converted into a superheated steam. That superheated steam will flow in the upward side after getting converted and will flow out through a boiler shell through a valve V2 which is open. Okay. That hot gases after hitting that tube will flow into a bottom passage which is formed inside a brick construction, and the same process of a Lancashire boiler will be repeated. But at a time when we don't require a superheating of a steam, so what we are going to do? So we are going to close that damper. Damper will be completely closed. Now can I say that hot gases from a main tube will directly bypass that portion and will enter into a bottom passage? That means it is not going to enter into a superheater passage. Okay, it will directly bypass and will enter into a bottom passage. This will be done when superheating is not required. So remember that case. Okay, so this is how this superheater is going to operate. Now let us see the things which I have written. So it increases the temperature of a steam above the saturation point. The steam generated above the surface of water is always wet. When a valve V1 and valve V2 are open and valve V3 is closed, so we can say steam passed through a superheater. Okay. Superheater uses high temperature gas to convert a wet or a dry steam into a superheated steam. Now what are the advantages? So first is steam consumption of a turbine or engine is reduced. Second, erosion of a turbine blade is eliminated by passing a superheated steam. And third, thermal efficiency of a steam plant is also increased. Okay friends, so with this we are completing with our chapter of boiler. We'll meet in our next video. Till then, stay tuned and thank you all.